Students, in this class we will learn how to solve this question. Integral dx divided by root of x times 1 positive third root of x. Now I can rewrite this given question in this fashion. Now how do I do that? Just for the sake of explaining, I'm going to be writing x, which is raised to the power of 1 over 2 in this fashion, and then multiply it with 1 positive x raised to the power 1 over 3. Then what would I do? I would just move this to the numerator. Now how could I move that to the numerator? Just by reversing the sign of x raised to the power 1 over 2. So if I were to do that, this would go to the numerator. Now, so we have been given this as a question, so we are expected to solve this. So now my objective would be to evaluate x raised to the power negative 1 over 2 divided by 1 positive x raised to the power 1 over 3 times dx. I've got 1 positive x raised to the power 1 over 3. What I'm going to do is I'm going to rewrite it as x raised to the power 1 over 2 raised to the power 2 over 3. Okay, so it is something like this. X raised to the power 1 over 3 is rewritten as x raised to the power 1 over 2, and that is raised to the power 2 over 3. Now this is same as x raised to the power 1 over 3, because you would have studied in algebra a raised to the power n raised to the power m is a raised to the power n times m, which can also be rewritten as a raised to the power m times n. So some algebra goes here. Now for the numerator, it's x raised to the power 1 over 2, retain it as it is, and then that has to be multiplied with dx. Now I am going to be making the substitution that x raised to the power 1 over 2 to be equal to u or some w, okay, raised to the power 3. Now why do I do this substitution? Because I want to get rid of this 3 in the denominator. That is the reason I am making the substitution. Now differentiating both sides, we get, so what happens when you differentiate x power half? That's going to be 1 over 2 times x raised to the power 1 over 2 negative 1 times dx. Now differentiating w cubed would give me 3 times w squared times dw. Now the left side can be rewritten as 1 over 2 times x raised to the power half negative 1 would give me negative half times dx, which is equal to 3 times w squared times dw. Now I've got x raised to the power negative half times dx in the numerator, so let me retain that x raised to the power negative half times dx and move this 2 to the right side. That would give me 6 times w squared times dw. So this is the substitution I would be making for the question. So therefore integral x raised to the power negative half times dx divided by 1 positive x raised to the power half raised to the power 2 over 3 can now be rewritten as integral. In the place of the numerator, it's going to be 6 w squared dw followed by 1 positive. In the place of x raised to the power half, I'm going to be substituting w cubed, and that has to be raised to the power 2 over 3. Now clearly the 3 that you see here can be cancelled, right? So that would be giving me 6 times integral w squared times dw divided by 1 positive w squared. Now the degree of the numerator and the degree of the denominator are one and the same. So what we got to do is we would be dividing w squared by 1 positive w squared. So that would give me 1 here. 1 times w squared is going to be w squared followed by positive 1. I change the sign, giving me negative 1 as the remainder. So therefore W squared divided by 1 positive W squared can be rewritten as 1 followed by the negative sign followed by 1 divided by 1 positive W squared. So this is the representation I have got. So using that, it's going to be 6 times, in place of W squared divided by 1 positive W squared, I would be writing 1 negative 1 over 1 positive W squared times dW, close the parenthesis. So this is equal to 6 times integral dW negative 6 times integral dW divided by 1 positive W squared. Integral of W is going to be, integral of dW is going to give me W followed by 6 times. This is actually tan inverse of W. Of course, you need to place a constancy. I will place it at the end. But we know that. What do we know? We know that W is actually, what is this? W cubed is 1 x raised to the power 1 over 2. So W is going to be, so you can write it. We know that W cubed is 1 over 2. So therefore W is going to be, you move the 3 to the other side, that will become third root of x raised to the power 1 over 2, which can be rewritten as x raised to the power 1 over 2. It's a third root, right? So it's going to be 1 over 3 there, which is nothing but x raised to the power 1 over 6. So just place it there. So this is going to be equal to 6 times x raised to the power 1 over 6 negative 6 times tan inverse of, in place of W, it's going to be x raised to the power 1 over 6. I can rewrite this in a proper manner. It's going to be 6 times 6th root of x negative 6 times tan inverse of 6th root of x positive constant c, which is the solution for the given question.